Hey, my name is Quinn and I'm a developer with Scout APM. In this video, I'm going to show how we can integrate Scout into a Django application, as well as how we can use Scout Insights to quickly identify and fix performance issues. We have a simple demo app here, just a to-do list, and we'll be instrumenting this with Scout. If you want to follow along, I'm just looking at the Scout docs here. We have a short guide on setting this up with Django. Very straightforward. First thing you're going to do is pip install Scout APM in your project. So we'll just do that here. From there, we're going to make a couple modifications to the settings.py. You're going to add a new app at the top of your installed apps list here. And again, we can just reference this. So Scout APM Django. Just going to copy it over there. And then there's a few settings you'll want to add as well. So we'll place those here. The Scout key you're going to find in your organization settings. I'm just going to use an environment variable here. So we'll do like that. And then for the name, this is just what the app will appear as in Scout. So video demo app. Sure. From the docs, we can click over here into logging. We have some logging configuration. This is optional, but it can be nice in a dev environment to be able to see Scout logs come through. So I'm going to go ahead and copy this. And this is also just going into your settings.py file. So we'll just paste that here. So once you've installed Scout APM into your app, and you have your Scout key set either in your environment or in this file directly, your app should be ready to report data. In our example, we're using a Docker Compose file to define the app and the accompanying Postgres database. We can start up both with running Docker Compose up. Now, if you added that logging configuration from earlier, you should be able to see Scout logs come up right when the app starts. That's a good sign things are working. To generate some data, I can load my simple view, interact with the API by deleting some to-dos, and filtering by the author. Once we log into Scout, we should see that our new application is reporting data. So we'll go ahead and open it up. We're greeted by the overview page, which provides at-a-glance information about all our traces and endpoint performance, as well as some powerful insights in these tabs here below. For now, we're going to focus on the N+1 insight. We see that Scout is identifying an N+1 query inside of this get to-dos endpoint. We can click in to see more info about this specific trace. From here, we can see that Scout has highlighted the trouble query. We can view the exact SQL statement that's being executed, as well as the exact line of our resolver code where it's happening. Let's open up our editor and take a look. On the left, we're looking at our resolver code, and on the right, our database models that we're working with. Looking at these models, observe that we have to-do and author classes. Authors are related to to-dos via a foreign key relationship. This is how we traditionally model a many-to-one relationship in Django. There are many to-dos belonging to one author. Now, if we change our focus back to the resolver code, we see that it first gets all the to-dos by title, and then iterates through those to-dos, printing and returning the to-do title and the to-do author's name. However, since authors are related to to-dos via a foreign key, the author data has not been queried yet. So to access this attribute of the author, Django has to perform a separate select query to get the author for each to-do in a loop. This is very inefficient and a textbook example of an N+1 query, but one that can be easily missed if it wasn't for Scout. To fix this instance, I'm going to use the Django method selectRelated, which will also select all related records, in this case the authors, via a join. Now, when we iterate through the to-dos, we'll already have all the associated author records in memory, and Django doesn't need to query the database any further. Let's reopen the Scout app. If we focus in on our get to-dos N1 endpoint, we can instantly see the difference our changes have made, with this red bar representing the time spent in SQL execution. The difference is an order of magnitude. Furthermore, we can see the new SQL statement that's being executed, just one time for each request, instead of hundreds of selects for each to-do object. This is just one powerful insight that Scout APM provides. As we've shown, it's so easy to add your Django app into Scout, quickly identifying long-running or inefficient N+1 queries, and see your improvements reflected in near real time.